Welcome back, guys. This is part 2 of our introduction video to trigonometry. In this video, we're going to do a real quick refresher on what we did in the last video with labeling triangles and some naming conventions, and then we're going to hop right into our trig identities and trig ratios. All right, so first of all, just a quick review of properties of triangles. Remember that we label all of our angles with capital letters, and we label all of our sides with lowercase letters. Now, remember that all angles in a triangle add up to 180 degrees. And triangles with a 90-degree angle contained within them are called right triangles. And the side opposite 90 degrees is always called the hypotenuse. And then when it comes to solving triangles, if we are looking for missing sides, a lot of times we can use the Pythagorean theorem. And Pythagorean theorem is a squared plus b squared equals c squared, and c is the hypotenuse. Now, the next thing that we looked at in our last video was labeling of triangles. And so if I want to label a triangle, I label my triangle based on my angle location. So if x is my angle, looking across the triangle would be opposite. Looking across from 90 degrees would be hypotenuse, and then the side here beside the angle would be adjacent. Now, if you have not watched the first video, it's really important that you go back and watch the parts about naming conventions, because this is the first step in solving all trig problems. And a lot of times when I go back and troubleshoot or see where students made their mistake, it almost always starts with the labeling of the triangles. So it's really important that you're able to label a triangle. All right, so we're going to jump right into our primary trig ratios. And when we're looking at trig, we're looking at 3 ratios: sine, tan, and cosine. And so up to this point, you might have seen these buttons on your calculator. Lots of people will call it sin. It's not sin, it's sine. It's sine, cos, and tan. So not sin, cos, and tan. If you ever have me for math, those are kind of pet peeves of mine. Make sure that you're saying them accurately. So sine, cosine, and tangent. And so we're going to be using those 3 buttons. Something else that's important once we start getting into trig is that our calculator is in the right mode. A lot of times people will ask me if they get a question wrong, if their mode matters. The only time your mode matters is when we're dealing with trigonometry, and so we'll get into that in a minute. All right, so we know that tan, if we're looking at some trig ratios, these are things that other people would have already figured out. They would have, back in history, they would have done lots of calculations and figured out that the function tan of an angle is opposite over adjacent. So this is just a ratio that you're going to be using. So we're not deriving where we get it from. We're just going to use that information that we already know to solve other problems. So tangent of an angle, so this angle symbol here is called theta. So it's a Greek symbol. We often use it for angles. So the theta is the symbol for angle. We know that tan theta is opposite over adjacent. And we know that sine is opposite over hypotenuse. So sine is opposite over hypotenuse. And we have cosine, which is adjacent over hypotenuse. And so we're going to work with all 3 of those ratios throughout. Now, if I wanted to figure out what these ratios were and I wasn't given a formula sheet, I can use a mnemonic device called SOHCAHTOA. And so this stands for sine is opposite over hypotenuse. Let me write that again here. So cosine is adjacent over hypotenuse, and TOA is opposite over adjacent. Notice capital letters for our angles and small letters for our sides. SOHCAHTOA. Now, funny story, maybe not so funny, but the first time that I remember learning about trigonometry, I was in math class. I learned it in junior high, but the first time I remember hearing SOHCAHTOA, I was in grade 10 math class with one of my teachers, and I remember he said SOHCAHTOA, and all I heard was suck a toe. And I couldn't understand why my math teacher was talking about toes in math, and it grossed me out. And I don't think I remember anything else from that lesson other than SOHCAHTOA. SOHCAHTOA, I heard suck a toe. It's stuck with me all these years, but it is not suck a toe, it's SOHCAHTOA, sine, cosine, and tangent. All right, now when we get into trigonometry, we're going to have to make sure our calculator's in the right mode. But before we get to that point, let's look at how we can set up some of our trig ratios. So again, we have SOHCAHTOA. I'm sorry if I've given you that bad visual now, but I had it from all the way back from grade 10. SOHCAHTOA, we're going to set up our primary trig ratios for angle A. Now, when we're starting with angle A, that means we're going to label our triangle based on that angle. And so if this is my angle here, looking across the triangle, this would be my opposite. Looking across from 90, this would be my hypotenuse. And that makes this adjacent because it's the side that's beside the angle. So if I wanted to set up my trig ratios, sine of angle A is opposite over hypotenuse. So opposite is 5. I'm not going to bother putting the units in there. Sine of angle A would be 5 over hypotenuse, which is 13. So this would be my primary trig ratio, 5 over 13. Cosine of angle A. Cosine of angle A would be adjacent, which is 12 over 13. And then tangent of A would be opposite, which is 5 over adjacent, which is 12. Now, if I were to take and change up which angle I'm referring to, let's say I want to refer to angle B this time. If I decide to set everything up based on angle B, this changes my labeling. 12 becomes opposite. 13 stays hypotenuse, that doesn't change, and my adjacent would be the 5. So opposite and adjacent often get mixed up, and so drawing that line across the triangle sometimes helps with that. If I'm looking for sine of B is opposite over hypotenuse, so opposite is 12, hypotenuse is 13. Cosine of B is adjacent over hypotenuse, so 5 over 13. And then tangent of B is opposite over adjacent, so 12 over 5. Notice how, based on my angle, my ratios change. All right, now if you're ever asked for, let's say, tan of 0.3. On your calculator, you can type in tan of 0.3, but mode is going to matter. So in our calculators, if you need to check the mode of your calculator, you're going to click on the mode button, and you need to make sure that your calculator is in degree mode. Now, often when you first start on your calculator, you're going to see it in radian mode. If ever I clear your calculator, or someone else clears your calculator, or you clear your calculator defaults to radian mode. It's really important that you always go and change that. So if we were doing final exams in class, final exams in school, and we came around and cleared all your calculators, you would have to remember to put your calculator in degree mode. So you might be asking, well, what's the difference between radians and degrees? It's just a matter of units of measurement. So just like we measure in centimeters and inches, we can measure angles in radians and degrees. We have done everything up to this point in degrees, and we'll continue to do it in degrees until grade 12. In grade 12, you're going to actually look at what a radian is, and you're going to look at how to convert between radians and degrees, and then you're actually going to start working with functions in radian mode. So in grade 12, you're actually going to be switching back and forth between modes. But up until that point, all through grade 10 and all through grade 11, you're going to be using degree mode. So to change your mode, you just click on the degree and make sure it's highlighted, and then you can second quit out of there. If I was being asked to find tangent of 0.3, be tan of 0.3, I would have 0.005. If I was asking you for sine of 65, sine of 65 would be 0.906. If I wanted to, let's go with a ratio that I might know a little better here. If I was looking at a 3, 4, 5 triangle, so let's say 3, 4, 5 triangle here, and I wanted to figure out what that angle was. Let's say this is about 30. Let's say if I went tan of 37. So let's say that I had measured this and I knew that this was about 37 degrees. Well, if I wanted to do tan of 37, so tan of 37 degrees would be 0.75, which is about 3 over 4. If I wanted to do opposite over hypotenuse, so that would be sine. So sine of 37 degrees would be about 0.6, which is what 3 over 5 is. If I wanted to do cosine of 37 degrees, I should get about 0.8, and I do. So again, sine, cosine, and tangent just represent a ratio between our sides. All right, so let's get into some solving of trig problems. Now, if I'm ever asked to find a missing side length, I'm going to do 3 things. First of all, most important, label your triangle. Then once you've labeled your triangle, you're going to look at your formulas and decide which ratio you need. You're going to set up your ratio and you're going to solve. So I'm going to look at 3 examples here. So the first example, I have 54 degrees and I've got an x and a 12.1. So the first thing I'm going to do is label my triangle. And so I label based on my angle. So if this is 54 degrees, looking across the triangle, this is opposite. And looking across from 90, this is hypotenuse, and this is adjacent. Now, using SOHCAHTOA, I'm going to decide which ratio I need to use. So I have 54 degrees. I'm looking for opposite, so I need to use opposite. And I have adjacent, so I can check those off. Well, the only ratio that uses both opposite and adjacent is tangent. So if I look at my formulas, tangent of an angle, sometimes you'll see it as an x, sometimes you'll see it as an angle, tan theta is opposite over adjacent. So I start by writing out my ratio. Now, once we get more into trig, I'm not going to expect to see the formula, but I will expect to see a ratio with numbers. So tan of the angle, so tan of 54, tan of 54 degrees. Degrees are important because radians don't have units. Degrees have that little degree symbol. So if you don't write the degree symbol, I'm assuming you mean radians. So degrees, writing that degree symbol is important. So tan of 54 degrees is opposite, which is x, over adjacent, which is 12.1. Now, if I want to solve this question, you can picture this being over 1. I have tan 54 equals x over 12.1. Might be even easier without doing that. If I've got it over 1, I'm going to picture myself cross multiplying. But if I want to get x by itself, what I have to do is multiply both sides by 12.1. So I'm going to multiply both sides by 12.1. And rewriting that, what that would give me is x equals 12.1 times tan 54. Again, units are going to stay there the whole time. So on my calculator, what I'm going to do is 12.1 times tan 54. So 12.1 bracket tan 54. And I can actually just write it as 12.1 tan 54 without the brackets, and I'll still get the same answer. Now, something that's important for us to note here, tan is a function, and so when you hit the tan button, it automatically opens a bracket for you. If you were to type tan 54 times 12.1, you have to remember to close your brackets. If you don't close your brackets, you're going to have this, tan 54, forget to close your brackets, times 12.1. And then we get the wrong answer. Now, I was one of those students who often forgot to close my brackets. So for me, what you'll often see me do is I always put the number first. Because if I put 12.1 times tan 54 and I forget to close my bracket, it's no harm, no foul. I've already got my answer. So this will be 16.7, and my units are yards. Now, when we're rounding, unless you're told otherwise, you round side lengths to the nearest tenth. And we round angles to the nearest degree. So unless you're told otherwise, this is sort of our convention for rounding. Side lengths to the nearest tenth, angles to the nearest degree. So we have x here equaling 16.7 yards. All right, let's take a look at a couple more examples here. So in the next one, we have 34 degrees, 30.5, and x. So again, the first thing we're going to do is label our triangle. So looking across from 34 degrees, this is opposite. Looking across from 90 degrees, this is hypotenuse, and that makes this adjacent. So looking at SOHCAHTOA, we have opposite. We're looking for opposite. And we have hypotenuse. So the one that we're going to use is sine. So looking at our formulas, sine theta is opposite over hypotenuse. So we've got our triangle labeled. The next step is to set up our ratio. We know that we're using sine. So filling in what we know here, we have sine of 34 degrees equals opposite, which is x, over 30.5. All right, so when the number is on the bottom, okay, we're going to be multiplying by 30.5. So this gives us x equals x equals 30.5 times sine 34. Putting that into our calculator, again, making sure our calculator's in degree mode. Unless you change things, your calculator should be in degree mode. But whenever I do trig, the first thing I do when I turn my calculator on is check my mode. But I'm going to be going 30.5 times sine 34. And that gives me 17.055. Rounding that to the nearest tenth is 17.1 centimeters. All right, now let's look at our last example here. We've got x, 32, and 12.5. So setting up our triangle or labeling our triangle, we have adjacent, and we have hypotenuse, and we have opposite. So using SOHCAHTOA, I have adjacent, and I'm looking for hypotenuse, so I'm going to be using cosine. Formula is cosine theta equals adjacent over hypotenuse. So cosine of my angle is adjacent, which is 12.5 over x. Now this one, my number is on the top, so I can treat this like a cross multiplying situation. I can put this over 1 and I can cross multiply, and that would give me x times cos 32 equals 1 times 12.5, which is 12.5. Now to get x by itself, we have to divide by cos 32. So my step would be x equals 12.5 divided by cos 32. Now, if I was looking at this here, if I've got cos 32 equals 12.5 over x, what you'll hopefully start to see as a pattern is if my number is on the bottom, like in that last example, if my number is on the bottom, I'm going to just cross multiply 30.5 times sine 34. Over here, I am doing the same thing. I'm cross multiplying and dividing. So I'm going to go 1 times 12.5, which is just 1, divided by cos 32. So if the number's on the top, it's just going to be 12.5 divided by cos 32. So on my calculator, I'm going to take 12.5 and divide by cos of 32. Gives me 14.73973 and so on. Rounding to the nearest tenth, we have 14.7. So x equals 14.7 inches. Again, make sure you're remembering your units all the way throughout. You don't need to write them in during the question, but as our final step, we need to have those. All right, so looking back at these examples here, you start off by labeling your triangle, find the right formula, and with your formula sheet, you don't necessarily have to do the check marks for SOHCAHTOA. You can just look at your formulas and see which one you have enough information for. But set up your formula, set up your ratio, and then solve. If the number's on the bottom, you're going to multiply. If the number's on the top, you're going to divide. Now included in Google Classroom, I have posted a handout of filled in notes where I've shown you every single example for sine, cosine, and tangent that you could see, and showing you how to solve, along with some other word problems. So I would suggest that you take a look at those notes, and that'll give you some more practice and more notes on this concept. Now, what we haven't looked yet is what if we have a missing angle. Now, if you've looked on your calculator right above sine, cosine, and tangent, we have a sine -1, a cos -1, and a tan -1. And those are what we use when we're solving for an angle. So if I were to tell you that tan of an angle equaled 0.5, and I wanted to figure out what that angle was, I could go to my calculator, and to get the angle, if I had something like here, let's say tan x equals 0.5, and I asked you, how do you get x by itself? You'd probably say, well, divide by tan. I can't divide by tan, though, because it's a function. So if I had 4x equals 12, I can divide by 4 on both sides and get x equals 3. But when I'm working with trig functions, because it's a function, I can't just divide by tan. Instead, I have to do what's called the inverse. I have to take the inverse. So if I have tan theta equals 0.5, to get the theta, I have to do the inverse. So theta is tan -1 of 0.5. So on my calculator, I'm going to go second function tan and type in 0.5. And I get 27 degrees. Okay, so the theta here would be 27 degrees. So the way that I'm getting this is I'm going second function tan. Now, if I had given you sine of theta equals 0.5, then I can do that on my calculator as well. To get the angle by itself, I'm going to go second function sine 0.5, and that gives me 30 degrees. Now, 30 degrees is a special angle that you're going to learn a lot more about when you get into Math 20 and Math 30. All right, so solving for angles, we do the exact same thing. We're going to start by setting up or labeling our triangle, setting up our ratio, and then solving. So we have our angle here. Looking across the triangle, this is opposite. Looking across from 90, this is hypotenuse. Now, when I'm solving problems, I often don't label the side that I don't need. So I have opposite, I have hypotenuse. I don't need adjacent, so I'm not even going to bother labeling it. Sometimes that makes it easier for identifying which formula you're using. So I have opposite and hypotenuse. If you remember from SOHCAHTOA, opposite and hypotenuse would be sine. So my formula is sine theta equals opposite over hypotenuse. Again, I don't expect you to necessarily write the formula, but I do expect that you write the correct ratio with the numbers filled in. So sine of the angle, sine of theta, is opposite, which is 22, divided by 32. Now, to get our angle by itself, theta is going to be sine -1 of 22 over 32. So to put that into our calculator, we would have second function sine 22 divided by 32. And that gives me 43 degrees. Remember, with angles, we round to the nearest degree. So 43.4 becomes 43 degrees. Now, when it comes to angles, the only time we use sine -1 is for trigonometry. Of course, for trigonometry, but for when we're solving for a missing angle. So while I do expect to see your ratio written out, I am okay with you just doing these steps right here for solving for angles, because ultimately that's what you're going to be doing is the inverse. Now, for the next one here, if I want to label my triangle, I've got my theta. This side here is adjacent, and this side here is hypotenuse. So the ratio that uses adjacent and hypotenuse is cosine. So cosine of the angle is adjacent over hypotenuse. So I'm filling in everything because these are notes. But again, I would be okay with you going straight to those last two steps. So cosine of the angle is 7.6 divided by 9.2. And to get the angle, I'm going to do the inverse function. So cosine -1 of 7.6 over 9.2. So this would be sort of the bare minimum. I would expect to see this ratio here, that theta is cosine -1 of 7.6 over 9.2. At that point, we're putting that information into our calculator. So second function cos 7.6 divided by 9.2. Close your brackets, enter, and we have 34 degrees. All right, so that's the basics of trig. That is all that we do for solving triangles, and this is basically half of our unit already right here. We are going to be spending a few days going through some trig problems, right triangle problems. We're going to go through how to draw diagrams based on a word problem, and then the second half of this unit is to get into solving problems that involve more than one triangle. But this is essentially the entire piece in terms of solving right triangles, and now it just comes down to us doing lots of practice. All right, now if you need some more practice with setting up your ratios, there is a link that I'll put online. However, it does involve Flash, so it doesn't work on all browsers unless you have your Flash enabled. But there's something you can look up called Trig Mini Golf, and I'll make sure to put the link on the website. But if we click on Google for Trig Mini Golf, this is an interactive. I use this when I used to teach trig in junior high. But Trig Mini Golf is just a game basically, but a mini golf game that helps you with setting up your ratios. I use this often with my 10-3s and my 20-3s. So we start off with this first example here. It says if angle R is the reference angle, 5 is, well, looking across would be opposite, and 10 is adjacent. So it just gets us really familiar with labeling. The next part then, it says if we're calculating R, so we have opposite and adjacent, that means we're using tan, and tan is opposite over adjacent. If we are using tan, then we're going to have tan of the angle, so tan of R, and opposite is 5 meters, adjacent is 10 meters. Now, if you made a mistake, they would actually correct it for you and show you what the proper step would have been. And then the computer actually does the calculation for you. So if I want to figure out this angle, it would be inverse of 5 over 10, or inverse tan of 0.5, which is 27 degrees. So again, this game is more for helping you get everything set up. But play through a few rounds of mini golf, and you will have absolutely no problem setting up ratios. So if you're looking for a way to practice setting up your ratios, this is what I would recommend. All right, that's all I've got for you guys. We will see you soon.